Well, I am waiting for the new HF transceiver to come. I have this power supply, and I would like to test how clean the power output is. One way to do that is with an oscilloscope. This oscilloscope right here is fairly inexpensive, very inexpensive for an oscilloscope. It's under $200, but it's good enough for the job. We're looking for 60 Hertz, the power that comes out of the wall, to check if any 60 Hertz is in the DC output. These oscilloscopes are very easy to use and affordable for most people compared to those big bulky desktop oscilloscopes. They also have a battery, which is nice. I will connect the input to the oscilloscope to the output of the power supply. And the connections do not have to be great because we are only measuring the voltage. We're not drawing much power at all. I'll turn on the power supply. We see it goes right up to 13.8 volts, right where it should be. We're using channel 1. It's this one right here. This particular oscilloscope has 2 channels, but I am only using one right now. I'm looking for AC, so I'm not looking at the DC voltage because that's up at 13.8. That's too high for us to look at. So we'll look at the AC voltage. And I'm using the direct proportional voltage probe. Now, we have the scale, which is currently set at 50 millivolts, meaning the height of the graph is 50 millivolts. It's divided into 7 squares, and each of those squares, or 8 squares, and each of those squares represents a fraction of the scale. This scale looks pretty good right now because the disturbances in the current take up a fair amount of space on the graph, but not too much. We might be able to increase the precision. Changing the graph to 20 millivolts from the bottom to top gives us some more resolution to work with. We can also set the time. The time of the graph right now is 100 milliseconds. We're looking at AC line voltage, which has 60 pulses in a second. With these 1/10 of a second, we should see 6 pulses if there is interference in the output signal. One other option that can be useful is changing which mode you look at the signal. I'm not sure what YT means, but it looks like it takes the signal and then waits a little bit so that we can look at it and fills the whole screen with it. The other modes are roll, which keeps a rolling signal going across the screen. But that's hard to look at, and it limits the time to 100 milliseconds. That can be a limiting factor in other applications, but for us that's actually okay. For example, if I wanted to use a higher or a lower amount of time on the graph, and I lowered it down, you'll see it switches out of roll mode. That's okay for us because we're using this YT mode anyway. Gonna go back up to 100 milliseconds. Right there. So I will stop the counting at any point and examine the graph. At 1/10 of a second, we should see 1/10 of those 60 pulses. We would expect to see 6 pulses in this. You can kind of see them. There's one there, one there, one there, there, and there. I only counted about 4 there. This power supply is looking like it outputs a very clean signal. The disturbances in the general static that comes out of the power supply are much more significant than the pulses we get from the AC line voltage. If the graph was going up and down more than this, then I would be concerned and looking at maybe getting a different power supply that had better filtering. This power supply output, though, is very good. Another thing we can look at is how much deviation in the 13.8 volts there actually is. Seeing that the top to the bottom of the graph is 20 millivolts, we can fairly accurately calculate it. Looks like the signal goes about there and goes up a square, down a square maybe. So I'll give 2 squares, be fairly conservative. 2 squares is 1/4, because 2 out of 8 is 1/4. 1/4 of these 20 millivolts. 20 millivolts is 0.02 volts, and we're taking 1/4 of that. Gives us 0.005 volts is the amount that our signal goes up and down. How much that is of the 13.8 volts we are expecting from the output can also be calculated. And it's almost nothing. Seeing it in a percent shows us that it's just a few hundredths of a percent. Very little noise in the output of the power supply.